Okay, now we want to dive in a little deeper to some specific materials, continuation of our conversation. And I'm going to talk about our Markforged materials, and then Jose is going to talk a little bit more about our Stratasys options. Now, we're not going to talk about every material option that we have out there. We're going to just kind of focus on some of the most common materials that we use. So, um, the Markforged technology uses a composite material. It's called Onyx. So it's a base, that's their base material. So it's an FFF based process and or FDM based process. So that Onyx material is spool based, right? It's laid out layer by layer. The material itself is a composite, what that means, it's a multi-material mix, right? So it's a PA6 nylon plus continuous or chopped carbon fiber within the material. So that in and of itself, just printing with straight Onyx is a really great option. It's about twice as strong as it's about 50% as strong as ABS, and it's about twice as stiff as ABS. So just to kind of get your mind around that, it's a great option for just printing stronger parts right out of the gate. They do have two variants of that material. One is their FR version, and that means flame retardancy, and it's V0 rated. So that means it's it's passed all the tests for if you have an application that goes into auto, anything that is interior in an airplane cabin, a car cabin, truck, anything that's going to be exposed to people, right? And if it starts on fire, you don't want that toxic smoke and everything, the parts starting on fire and burning, right? So you have to have that V0 rating. Any material that goes inside those kind of environments need to have that rating. So if you have an application that needs that V0 rating, right? We have that available in the Markforged material. So they also have a variation of that, which is aviation rated or aerospace rated, where that when you have an application that needs that traceability. So when you're working in the aerospace industry sometimes, or regulated industries, you need that. Hey, where was that material made? What was the lot number? And trace it all the way back from the material manufacturing process all the way through. So if anything ever goes wrong, they can trace it back to see where the genesis of the issue occurred, right? Was it the part itself, or was it the material? So a lot of companies need that. So and then you have an ESD version of that material too. So electrostatic dissipation. So if you have components that can't have any static buildup, electronic cases, anything that would interfere if a part was able to, kind of have a static charge build up in the material. So that means that it won't occur. You won't get that interference from the static electricity buildup. So that's when you're going to use those materials. So Onyx is a great material just for stronger parts that have a great impact resistance and a little bit stiffer presentation. So those kind of applications that require that kind of need out of the material, those are great options. Now, the other facet of what Markforged brings to the table is their ability to not infuse, but lay down continuous fiber within the part. So the Onyx material is kind of the shell and what most of the parts build out of, but you can put layers of continuous fiber within the part. So that's what Markforged is known for really strong, lightweight parts. And they have 4 options there. So they have their carbon fiber reinforcement filament. So you're printing the part out of Onyx. You use the software to put continuous fiber in the XY as those parts are being built to offset the pressure or the forces being exerted on that part. So we can work with the customer, understand, if you need, if it's an end of arm robotic tool or a bracket inside of a vehicle, we can help craft that fiber routing within the part to offset those forces. So, if it's a compressive force, then you want to put rings in it. If it's a flexural force, you want to make sure that that fiber is run from end to end in the part. So when you try to flex it, that force is spread out throughout that continuous fiber. So we have carbon fiber, which is the highest strength to weight ratio out of the fibers we offer. We have Kevlar reinforcement. So if you have a part that has some impact resistance or has a lot of cycle bends, it's good for that. It's good for parts that have a lot of, if it's flexing a lot over time, that will help with that fatigue, right? The Kevlar will help offset that. And then we have a high strength, high temp fiber. So if you have a higher heat environment under the hood of a car, let's say, we can go up to 145 C with the Onyx and the high temp, high strength fiber. So that's great if you have a high temp scenario that you need a really strong part. And then you have fiberglass, which is kind of it still does a great job, and it can really improve the strength and the functionality of a part, but it's our lower cost option in terms of continuous fiber. So those are the options there, and just the technology itself and the material itself. What we see a lot of use cases for is just something that is, maybe it's a metal replacement. A lot of what we're seeing is not only part manufacturing, but just production. Soft jaws, end of arm tooling, stuff, and a lot of automation equipment has a lot of custom work holdings, right? And this is a great way to have a customized work holding that will, you can engineer it or design it to hold a specific, need. It's not just off the shelf kind of, but it's also non-marring, which is important because a lot of times you have tooling or that's out of metal and you can scratch your product or whatever. So this is a great option if you have work holdings. And then just brackets and anything that you need a lightweight, high strength material. That's the Markforged is one of the best options that we have available. So now Jose is going to talk a little bit more about our Stratasys and a few options there.
Yeah, no, thank you again for going that breakdown of the Markforged. To me, it's pretty interesting how you can mix a lot of different fibers into that base material. Whereas Stratasys, it's just running that pure material that they offer. So I'm going to start with our most cheapest material option for the Stratasys machines. So those two are going to be your ASA and ABS. So with ASA and ABS, very similar, just the only difference that those materials will vary is that ASA is acrylic based, so it's gonna be better for your parts that are gonna be exposed more to UV because the acrylic is gonna have more resistance to that to not have that color being faded. Whereas the ABS, it's not gonna have those properties to combat that. We have a lot of different color options too that Stratasys provides. We have black, yellow, red, green, every color in the spectrum that you can imagine. So if you're looking for something that you want to do a quick, budget-friendly prototype, definitely ASA and ABS is going to be your go-to materials for those applications. You can use them for housing, for toys. They're pretty good properties in that sense for you to do those applications. What's really nice too about Stratasys is just the capabilities of how big of volume parts that you can do. So here we have a 450 MC, well, two of them, and one F900. So the 450 MC can print a part up to 1 cubic foot, and the F900 is about up to 3 cubic feet of volume of a part. So pretty large parts that you can get printed. So it's pretty cool, big machines. What's really interesting too is that with the machines, you can go into the software and really change how the FDM process is gonna create the part, meaning like how the structure is in the cross-sectional layer. In the software, you can do sparse, double sparse, or a hexagram, and 100% infill, which basically it's that's gonna really change the costing depending on how dense of material you want to put into that part. But two, you can also reduce that by choosing which sparse or hexagram to reduce the material, but also still giving that integrity of the structure in that sense. Another materials that we offer too in the Stratasys would be our PC. It's also incorporating ABS, PC ABS. That's a little bit more of a higher grade versus your ABS and your ASA alone. So with the PC ABS, that one there, it's a little bit more rigid. So anything that you need for fixturing wise, and as well as prototyping, that material is going to be a really good option for you, just because the mechanical property is going to be a little bit stronger, and the cost a little bit more versus higher end grade materials that we do offer in the Stratasys that I'll be going in shortly. But what's really neat about this material too is that it's also FDA approved in that sense, that you can use in the food industry. And with that, that can be something that's really important. And so if you need a material option for that, definitely PC is a good one to choose. We only offer that in white. That's only the option that we have for that material. And yeah, no, that's a good one there. The next one that we can go into, that like more higher end grades, would be our Ultem material. So we have two different variants of Ultem. We have Ultem 9085 and Ultem 1010. So how I rank it's Ultem 9085 and Ultem 1010 is a little bit better. So first is Ultem 9085. This one also is food grade approved, or FDA approved to use in food applications. It has pretty good heat and strength weight ratio for this material property. So for this one here, you see it a lot being used for like tooling for stamping in that sense. For 9085, you can use it for fixtures as well, for tooling that you need to in order for you to do an assembly process. And for Ultem 1010, that's where you're going to see it more in your aircraft or aerospace applications. So for Ultem 1010, I was looking at the data sheet earlier. It's just pretty fascinating what the material properties of that material are. That material can withstand up to 217 degrees Celsius under working load, and it has comparable yield strength to mild steel, 250 megapascals. So for that one, it's a very premium material that costs quite a bit. But if you're needing something that requires having a lot of strength, low weight, as well as being aerospace approved or food grade approved, definitely the Ultems is going to be the best material option that we have that we can run in house. And with the Stratasys, just the capabilities of those machines too, where the tolerancing, they can hold a plus or minus 5 thou, which is pretty great in the additive industry. I know a lot of machines there can be a little bit more wider, like when the last process that went through with HPMJF, those are a little bit more wider. But if you really need to have tight tolerancing, Stratasys is really, really good for those applications.
Yeah, and then just generally, we just touched on a few of the material options out there, and as the additive market, growing, evolving, you're seeing a lot of the lower end systems. The capabilities are starting to, kind of close the gap between the industrial machines and then maybe some of the prosumer kind of machines. So we're seeing a lot more equipment coming on market that people are bringing on or having access to, and the material options then are really starting to satisfy some niche needs, right? When it first came out, you only had some base materials, but now you're really seeing the Ultems and the Peaks and carbon fiber filled nylons and all these kind of options that address the problems that people are trying to solve. So the best way to really understand what you need is to, give us a call and we'll sit down, or, jump on a Zoom call, or I like to get out of Chicago in the wintertime. So, we're always open to sitting across the table with our customers, really understanding the problems they're trying to solve and what path is the best to take, right? There's so many options out there. Even it's hard for me to keep up with all the changes, especially in the additive industry and all the material options out there. So, but that's when we understand what you're trying to solve for, what the application is, then we can get in the right footprint faster. So you don't have to go through that discovery. When people are trying to do that on their own, sometime, it's great to go to a site. You can throw a part in there, get it quoted. You have all these options. Not quite sure a lot of times. And then we always hate when someone tries to do it on their own. They don't get the results they're looking for. And if they would have just had a a quick 10-minute conversation with us, maybe. That's why we look at all the parts we see coming through, so we can understand a little bit better what it looks like, the geometries, what the best process and material options would be. And then when we have the opportunity to talk to people about what they're trying to solve for, we really can narrow down what's the best path again, and get that process, and so you don't have to start over from scratch and move forward again. So that's what I would suggest. So come to our website, uptivemfg.com, and we have a contact us page, or just submit your files, and then just put in the notes, hey, I want a conversation with you guys, and or just reach out to Jose and us. And now that we're splashing on LinkedIn and social media, now that Claudia's making us do all these, you'll be able to reach out and know who you're talking to. You'll put a face on it. So thank you again for spending the time and listening to our discussion on materials. Thank you.